Welcome back, everybody. Ready to dive into another really cool paper with me.
Always excited to see what we've got.
Okay, so this one, it's called Autonomy of Experts Models,
Okay.
and it's by Ang LV and their team.
hmm
And it basically asks this question. What if AI experts could decide what problems they're best suited for?
Oh, that's cool.
Right, like how much better would our AI systems be?
Yeah, I mean, it makes you think about the whole way we build these systems.
Oh, wait.
It kind of challenges some fundamental assumptions behind a pretty popular AI model.
Which is,
Mixture of
oh
experts.
yeah, MOE, right?
Exactly. So remember how MOE works? You've got all these specialized AI
Probably like
experts.
a team of specialists.
Yeah, exactly. But then you've got this separate manager AI that's calling the shots, deciding which expert gets which task.
Okay, so it's like delegating, but in the AI world.
Pretty much, yeah.
But what if that manager AI isn't always the best judge?
Right. I mean, that's a big limitation with MOE, right? What if the manager messes up, sends a task to the wrong expert?
Yeah, it creates bottlenecks and inefficiencies.
Exactly. So what this paper does, it explores this pretty radical idea.
hmm
What if we just let the experts decide for themselves?
Okay, hold on. How do you even start testing something like that? Like, how do you move from this manager AI setup to something so different?
So they started with a pre-trained MOE model, but then they did something pretty interesting. They completely took out the manager.
Wow.
Yeah. And then they just let the experts self-select tasks based on these things called activation norms.
Activation norms.
Yeah.
Yeah.
Basically, it's a measure of how strongly an expert's internal signals fire up in response to a problem.
So it's like each expert has its own kind of internal sense of, yeah, I got this, or nope, not my area.
Exactly. It's like their confidence level for a specific task.
That's so cool.
And the crazy part, even without the manager and without any retraining,
Wait, really?
yeah, the model still did pretty well on different tasks.
So even without being explicitly told what to do, these AI experts had a pretty good sense of what they knew.
That's the thing, right? It's almost like they already had that understanding built in.
That's amazing.
This whole approach is called Autonomy of Experts, or AOE.
AOE.
Okay. And it really challenges this whole idea that we need a central controller to manage expertise in AI.
So like instead of this top-down management, we're talking about a system that can kind of just organize itself.
Exactly. Think about a team where everyone volunteers for the tasks they feel most confident about.
Yeah, that's a great analogy.
Right.
Okay, but I gotta ask, how does an AI expert actually figure out what it's good at? Like, how does that even work?
That's where things get a little more technical.
Okay, bring on the technical details.
All right, so with AOE, each expert kind of pre-computes this really compressed low-rank version of whatever input it's getting.
Wait, low rank? What does that even mean?
Think of it this way. Imagine you have this massive, super detailed image, right? A low-rank version would be like a tiny thumbnail of that image.
Oh, okay.
It still captures the essential info, but it's way smaller, way more efficient.
So each expert is basically creating a thumbnail of the problem to see if it's something they can handle.
Exactly. It's like a quick self-assessment, and then they compare that self-assessment with others.
Okay.
And only the ones who are most confident, they move forward with that task.
So it's like they're all putting their bids in, and only the most qualified experts get the job.
It's a really neat way for the AI to figure things out on its own, without needing that separate manager.
It's almost like they're collaborating, but also competing at the same time.
It's a fascinating dynamic for sure.
So this all sounds pretty cool in theory, but does it actually work? Does this self-selection actually lead to better results?
That's the million-dollar question, right?
Right.
And the researchers, they looked into this really thoroughly.
Okay, and what did they find?
Well, what they found was pretty remarkable. AOE, it not only performed as well as traditional MOE on a bunch of different tasks,
Okay.
sometimes it actually did even better.
Whoa, hold on. So we're not just talking about some theoretical possibility. We're talking about actually improving how AI solves problems.
Absolutely. And it gets even more interesting when you start looking at how those improvements happen. It's not just about overall performance, it's about how the expertise within the system develops.
Okay, so we've got these experts. They're choosing their tasks. They're doing well.
Yeah.
But how does that affect the whole system? How does AOE actually change the way the AI works as a whole?
That's a great question, and that's what we'll look at next.
Let's do it. Okay, so we're talking about how AOE changes the game in terms of AI expertise. But before we get too deep into that, I want to go back to something you mentioned earlier about efficiency.
Yeah.
Like this whole idea of AOE making better use of resources. Can you break that down a bit more for me?
Sure. So one of the things they looked at in the paper was computational throughput. Basically, how fast the model can process information.
Got it. So like how quickly it can crank through tasks.
Exactly. And what they found was AOE can actually achieve a really similar throughput to traditional MOE.
Oh, wow. Okay, so we're not losing speed for this, like newfound autonomy.
Yeah.
That's huge, especially when we're thinking about real-world applications where speed is everything.
Right, exactly. You need things to happen quickly.
Totally. But is there a trade-off? Like, is there something we're sacrificing for that speed?
Well, there is one thing. AOE, it does need a bit more memory.
Okay, why is that?
It's mainly because of the way the experts pre-compute those compressed versions of the input, remember, for their self-assessment.
Right, the thumbnails.
Yeah, exactly. So they need a little extra space to do their internal calculations before they decide which task to take on.
Okay, that makes sense. It's like they need a bigger workspace. But, I mean, given all the potential benefits we've talked about, the improved performance, the specialized experts, the more balanced workload, it seems like that little extra memory cost might be worth it, don't you think?
It's definitely a question of weighing the costs and benefits, right? Like with any new tech.
Right, of course.
But the researchers, they actually point out some interesting ways we might be able to optimize memory usage in AOE, so that's something to look forward to in the future.
Yeah, I'm sure they'll keep refining it. And they were able to train AOE models with, like, billions of parameters, right?
Yeah, they did.
That's a pretty good sign it can handle some seriously complex real-world stuff.
Totally. That scalability is really exciting.
It is. So we've talked about a lot here. I want to make sure we're all on the same page. Could we do a quick recap of the big advantages of AOE that we've covered so far?
Sure.
Hit me with them.
So basically, AOE is this whole new approach to building AI where the experts themselves decide what they're going to work on, based on what they think they're good at.
Right. And that self-selection leads to some pretty awesome outcomes.
Yeah. So we've seen that it can sometimes lead to better overall performance. Plus, you get more specialized experts, the workload gets spread around more evenly, and the AI even seems more confident in its decisions.
So it's like we're giving the AI more freedom. And because of that, it figures out how to use its skills more effectively.
Like that. It's like we're empowering the AI. And the best part is this all just happens naturally. You don't need some complicated external control system to make it work.
Right. It just kind of figures itself out. That's so cool. Now, I know the paper, it got pretty technical in places. Were there any other interesting findings that we haven't talked about yet, things that really stood out to you?
Oh, yeah, there were a few things. One thing that was really cool, they looked at how the experts' self-evaluation criteria changed during training.
Okay, so like how they decided what they were good at.
Yeah. And it turns out they actually adjust their internal signals over time, so they're more in sync with each other.
Interesting.
So it's like they're learning to work together as a team, even though they're kind of competing for tasks at the same time.
So it's like a healthy competition driving them to become even better.
Yeah, and it's really important for keeping the whole system balanced, making sure one expert doesn't get too powerful or take over.
That makes a lot of sense.
Yeah.
It speaks to like the robustness of the system,
Yeah.
It can self-regulate and prevent any one expert from becoming too dominant.
Definitely.
I also remember reading about different expert selection strategies being explored. What was that all about?
Yeah, so the researchers showed that AOE isn't limited to just one way of picking experts.
Okay.
It's more like a general principle, a framework that you can adapt to different approaches, depending on what you need the AI to do.
So it's flexible.
Yeah, exactly. And that makes it even more promising for all sorts of applications.
There was also that toy experiment, right? Where they trained these really small AOE and MOE models to classify different types of data.
Oh, yeah, I loved that part.
Me too. It seems so simple, but it gave us some pretty big insights.
It did. It was crucial for understanding how AOE deals with this problem called the distributed expertise problem.
The what now?
Distributed expertise. It's this thing that happens a lot in traditional MOE. Basically, the ability to do a specific task, it ends up spread out across multiple experts. So no single expert is really good at it.
Oh, so instead of specialists, you have a bunch of generalists who are kind of okay at everything, but not amazing at anything.
Yeah, exactly. But with AOE, the experts, they naturally gravitate towards specific roles.
So they become specialists.
Exactly. They become much better at what they do because they're focused.
It's like the difference between a general practitioner and a specialist doctor. Like, You'd go to a cardiologist for heart problems, not your family doctor, right?
Right. Perfect analogy. And having those specialists in an AI system, it could be really important for tackling tough problems that need a variety of skills.
Totally. And it all comes back to what we were talking about earlier about AOE being more efficient and ultimately leading to better results.
Hmm.
But even beyond all the technical stuff, this paper makes us think bigger, you know?
Yes.
It makes us think about what AI could become.
It really does. I mean, if AI can already figure out its strengths and weaknesses and organize itself like this, it raises some big questions about what's next.
Right. Like, how will this change the way we design and train AI in the future? And what are the ethical implications of giving AI this much autonomy?
Yeah, all important questions, and ones that we'll need to keep thinking about as this technology continues to develop.
Definitely. It's a conversation that's just getting started. Yeah, absolutely. It's definitely something we'll need to keep talking about. But before we get too deep into the philosophical stuff, I want to make sure our listeners know where to go if they want to learn more about AOE.
Yeah, for sure. I mean, the best place to start is always the paper itself. It's called Autonomy of Experts Models by Ang LV and their team.
Right. And for those who might want something a little less technical, more of a high-level overview,
Yeah.
I'm sure there are tons of articles and blog posts out there that break it down in a more digestible way.
Oh, yeah, definitely.
We'll make sure to link to some good ones in the show notes.
And if anyone's feeling really ambitious,
Yeah.
they could always try playing around with AOE themselves.
Oh, yeah, that's a great idea.
There's a bunch of open source tools and libraries out there that you can use to actually build and train your own AOE models.
Nothing beats hands-on learning.
Yeah,
Yeah,
probably. I
but
mean,
yeah.
you don't really understand something until you've tried it yourself.
Exactly. Who knows, maybe someone out there listening will discover some totally new application for AOE or a way to make it even better.
That would be awesome. That's what's so cool about this field. There's always something new to discover.
All right, so we've covered a lot of ground today. Any final thoughts you want to leave our listeners with?
Well, we've been talking a lot about these AI experts, choosing their tasks, getting more specialized, even collaborating within one system. But
Yeah.
what if we took that idea even further? Like, imagine a future where AI specializes not just within itself, but across entire networks of systems.
Whoa, okay, so you're thinking like a global network of interconnected AI experts, each one with its own unique skill set, all working together to solve these massive problems that humanity is facing.
Exactly. I know it sounds a bit sci-fi, but it's an incredible possibility to think about.
It really is, and it might be closer than we think. Well, thanks for joining me on this amazing deep dive into the world of AOE. Until next time, keep exploring, keep learning, and keep pushing the boundaries of what's possible.